All right, so I'm going to talk about just basic layout wiring, and I'll start by saying that this is one of those topics where there's a lot of correct answers for these things and a lot of opinions, both strong and not so strong. So this is the way I do it, the way the things that I think about. But I noticed that John's going to be doing a full clinic on this later in the fall, and I'm sure he's going to correct me in 100 different ways, things that I get wrong, because I know a lot of you guys have quite a bit of experience in this. But anyway, we're going to go over some basics here, and I'll start out with some general tips. I was going to put this at the end, but I think they're important. Start out, have a standard. It's not so important what that standard is, but have one. Use consistent wire types, wire gauges, insulation colors. Label everything if you can, color code things. For example, I have my main track bus is literally a black wire and a red wire. So I know which rail I'm looking at when I'm underneath the layout, and I keep that consistently everywhere. And I've got multiple main buses, and so I've got electrical tape every 6 inches or so. One's the blue bus, one's the yellow bus, and one's the red bus. And so again, when I'm looking under the layout, it's clearly marked when I'm working on it. I don't have to figure it out. It's still a mess. But second point, take good notes. This goes along with the wiring standard. Draw diagrams of stuff, even if it's just a pencil sketch. Write down, think about like when you crawl under the layout 5 years from now, what is it you're going to need to remind yourself of to figure out how to troubleshoot something. So if you even think you might possibly have to remember something, write it down, put it in a notebook or something, so that it's all recorded, because you will forget, and those wires do all look the same. Organization and neatness matters. This is one area where I fail rather miserably. Rat's nests are very difficult to troubleshoot and maintain, so try to keep things moving along, straight lines, and get grouped together, and tied off together neatly. Use wire ties and anchors to secure things so they're not moving around. Try to keep the wires out where they're accessible. Minimize the number of places. Sometimes it's unavoidable, but don't put things under things or behind things or inside of things where you can't get at them to work on them. So those are just the basic tips that I have that sort of apply to everything. Second point, wire types and gauges. I do N scale, so those mean small locomotives and not a lot of power. And so this is one of those places where if you're doing HO or O gauge track or engines, they need somewhat more power, and so you're going to need to scale things up a little bit on the wiring from what I do. Two basic choices: solid or stranded wire. They're good in different places. Solid wire, it's nice because it retains its shape. You can bend it in follow a particular route, and it'll stay there. It also, when you're putting it into screw terminals and things like that, the solid wire doesn't wear out as often, so and it makes a better connection. So if I tend to like it better for most things. Stranded wire is more flexible, and so it's better where you need, you're going to have things in motion, or you need a little bit of flex. So it does have good uses, but I personally tend to lean towards the solid wire for most things. Electrically speaking, for what we're doing, they're pretty equivalent, but that difference in the flexibility and the moldability of them can matter quite a bit on some of those earlier points about neatness and organization and so on. Generally speaking, I solder my wires to the track. We're going to talk about that in a minute, which means I use as small a gauge wire as I can get away with. Sorry, I'm a little off track. The gauge number for the wire, the larger the number, the smaller the wire is. It's literally the number of times it gets drawn out during the manufacturing process. So if you have a 14 gauge wire, that's what's inside the walls of your house. Sometimes it's 12, but generally it's 14 gauge, so it's carrying a lot of current, big heavy wire. 20 or 22 gauge wires are very, very small. You can go all the way down to 30, 32, or even smaller, but you wouldn't want to use that here. I use 24 gauge to solder to the track because, again, it's N scale and I want that wire to be as small as possible. But I keep those wires as short as I can. They go straight down through my foam, my layout about 6 inches, and they attach to my bus, which is either 14 or 16 gauge. Generally, bigger wires carry heavier loads for longer distances. You can almost think about it as like a side street versus the interstate. So your main bus wires and things you want to use as big as you can get away with, and you're comfortable molding around. I don't think you want to have 00 gauge wire unless you really have to, because that stuff is big and it's really hard to deal with. Just to be a little ridiculous on the large side, but 12, 14 gauge, if you can get your hands on it, it's cheap, and it's going to carry all the current you're ever going to need. Feeders, I keep them really small, again, because I don't want it to be visible in the scenic part of the layout on the track. But the trade-off, again, if I'm carrying any kind of current, I keep that as short as I can, because those short distance, it's both the distance and the size of the wire that manages or that controls how much current it can handle. When in doubt, use a bigger wire. Again, until it gets so big you can't manage it or it looks bad, on top of the layout, there is no such thing as a wire that's too big. The bottom line with your track wiring is it has to pass the quarter test. And what that means is you go anywhere on the layout and you drop a quarter across the rails, it should trip your short circuit protection. If you've got a fuse or a circuit breaker in your DCC booster, or if you're using the old automotive lamp tricks, whatever it is that you're using to protect your circuits, anywhere on the layout you drop a quarter, it should trip it. If it does, you're probably fine. If it doesn't, you need more wire or bigger wire. Trying to kind of move through fairly quickly through this. Connectors. There's a bunch of different types of connectors. You can solder wires. It's kind of hard to do upside down under the layout. It's a very solid connection, but it can also make it kind of brittle. So there's a lot of ways you can avoid having to solder. I personally use these 3M Scotchlok suitcase connectors. They get a lot of bad press, I think, from the mobile layout crowd. They originally were designed for cars, automotive applications, and they don't really hold up to getting banged around and moved around and all of that very well. I think they're suitable for a fixed permanent layout where they're not getting jostled very much for a long time. But if you're using if you're doing like an N track or T track or something like that where it's getting moved around a lot, you probably don't want to use these. A couple of alternates to that are these Wago lever lock connectors and the push wire equivalents of them. These are much more secure, and they're also can be disconnected and reconnected. At least the Wago lever ones can. So that gives you a little bit of convenience when you're changing things around. These are all carryovers from the home electrical stuff, and they can handle the 14 gauge size wires down to about 20 or 22. So they're pretty good for doing that if you need a little bit more robustness. Terminal strips, these are a classic thing. They're very secure. You can crimp the little spade lugs onto your wire, or just wrap the wire around the screw and tighten them down. They're very secure. They're very easy to change, or just disconnect something when you're debugging, but they're kind of expensive. And you're also kind of centralizing where everything is connected. So they can lead to some longer feeder wires than you might want. You've also got the Euro style versions, which are kind of equivalent, but they're just insulated in a different way, but they're still basically screw terminals. One thing that's kind of new to me are these Positap connectors. These look really cool. You put the thing on and you screw it onto the wire, and it actually drives a spike through the insulation into the bus wire. thing is they really, I guess you could use them with a solid wire, but they really only work with, they're designed to only work with stranded wire. But I've seen a number of people touting them as pretty useful. I personally haven't used them, but they look interesting. And then you got these custom, or shouldn't say custom made, but made specifically for model trains. These there's a lot of variants on this, but these Acculights little terminal boards that give you screw terminals. And here, oops, sorry, what did I do? Sorry, guys. Are we back? Okay. So these give you, you bring your bus wire into the left and right pairs of terminals, and then you can take your feeder wire off of the side terminal here. These are pretty convenient. They're not very expensive. Again, it gives you kind of that ease of the terminal strip, but also you can spread them out a lot of different, in different places, whereas the terminal strips are kind of centralized. The main problem I have with these is you have to cut your bus, which maybe not a problem. I gave a cost per tap over here on the side for all of these to compare, and that's for that cost is for both the red and the black rail, because you would need, for example, with the screw terminals, you need a pair of them, right? You need one for the red wire, one for the black wire, or red rail and black rail, if you will. Let's see. Okay, rail connections. Really, I think there's really only two basic options here, and this is one where some of the guys who've been around longer may know of something that I'm not aware of. But you've got either your feeder joiners, which can be either pre-made or you can make them yourself, or you can solder directly to the rail. The rail joiners are real convenient, and obviously, if you buy the pre-made ones, you avoid having to use a soldering iron. They're kind of expensive for what they do. And you also, the joiners themselves are not a very super secure electrical connection. They kind of work themselves loose, and you can get some unreliable electrical connection there. So I prefer not to use them myself. This is the one place where I think, soldering is really your definitely your best choice, as difficult as it can be to do. It's, practice a bunch and you can get pretty good at it. On the larger scales, you can probably get away with a little bit bigger wire. And I know even in N scale, a lot of people use standardize on 22 gauge. I don't know, maybe I'm a masochist, but I use a 24, which is, that much smaller. A little bit harder to work with, but it hides better. The larger gauge rails, you can use larger wires, which makes it easier to solder. I'll throw in a couple of tips there. Make sure that you scrape the side of the rail clean, or the bottom of the rail if you're soldering to the bottom. Scrape it clean and make sure you're soldering to bare metal. And put a heat sink of some kind on the rails to kind of help avoid melting your ties while you got the soldering iron close to it. I use some of those metal 1, 2, 3 machinist blocks to soak up some of that extra heat and keep it away from the ties while I'm soldering the rails. Little bit about track wiring types. I'm getting close to time here. This is an example of DC wiring. Nice thing about DC is it's low tech, right? You got switches, you got knobs, you got and wire. The downside is the wiring itself can get really complicated if you're trying to do anything realistic with your operations. And you're really kind of controlling the track instead of the trains, because what you're doing is you're assigning a block of track to the train, and you can only have one engine running in each space, or one set of engines, I guess. So there's pros and cons. I don't really want to get into details, but this is an example of what DC track wiring would look like. And finally, this is the DCC, which puts the smarts in the engine. You're sending instructions to the engine to tell it which way to go and how fast to go. With DC, you're just controlling everything with track voltage. But this is a lot more complex, a little bit more expensive, at least on the front end, because you got to have, you know, a throttle, you got to have a command station, you got to put decoders in your locomotives. But the wiring under the layout is dead simple. It's 2 wires plus all the feeders. You don't have all the switches and you know, this block and that block and the other block, unless you want to. So, well, that was basically it. So, unless there's questions, I'll cede
I did
I'll
not
cede the
see any
meeting back to
questions on chat.
Larry.
I guess if anybody has one, maybe you could temporarily unmute yourself if you have one. Or else we will just, I guess, hearing no questions, I guess we'll just go on to the next one with Randy Kaufman.
I have one question.
Yes.
Mark, what do you use for a soldering iron station, whatever?
Well, so at my desk, I've got a professional Weller soldering station for my electronics work. What I like to use under the layout is I've got one of these, it's a Hakko brand. It's a battery operated cordless soldering iron. You can find them in various places, but I was a little skeptical about the battery usage and the heat that I could get out of it, but I've been really pleasantly surprised. And since it doesn't have a wire, it's really convenient to deal with under the layout. Prior to that, I used just like a 40-watt standard soldering pencil iron that plugs into the outlet. I prefer the stations with temperature control and everything, but it's really hard to use that under the layout. It's much more of a workbench kind of situation.